physical geography, we have some of the very interesting formulas. So what we would be doing in this class is doing a quick revision of those important terms and formulas. Now the first important term that we would be discussing is the relative relief. Now when we talk about relative relief, I can simply say it is the difference of the maximum minus the minimum, or the actual variation in the height that occurs on the ground. So you have the highest elevation versus the lowest elevation in each of the grids, and that would be the relative relief of that region. Now why is relative relief important is again an important question. So first of all, we are able to understand the morphology of any specific region. So morphogenetic features are explained by the help of relative relief. The next is we are also able to understand how much dissection actually takes place in a mountain range. So you have the amount of dissection and the degree of dissection that can be analyzed with the help of relative relief. So we find out in every grid the highest versus the lowest. What is stream frequency? Now stream frequency is simply put number of streams of all order per unit area. So it's not just first order stream or second order stream, but it is the number of streams of all order divided by the total area, and that gives you the stream frequency. As you understand frequency, so you have the number of stream segments per unit of an area in a given watershed. Then what is dissection ratio? Dissection ratio is important. Dissection ratio is simply a ratio between the relative relief divided by the absolute relief. Now what is relative relief? We have already understood the difference between the highest and the lowest, and then divided by the absolute relief. So that is what is the dissection ratio. Now this dissection ratio varies from 0 to 1. 1 talks about a vertical cliff, 0 talks about a absence of dissection. That means there is no dissection that is present, and that is what is the dissection ratio. Now dissection ratio could range. When I say it's a very low dissection ratio, I would have a score of 0.2 or less. If I have a score of around 0.35, I say it is a moderate dissection ratio. A score of 0.7 plus would be a higher dissection ratio. So that is what is dissection ratio. Now why dissection ratio is important? Dissection ratio, we can say, is important because we are trying to understand the dynamics or the dynamic potential of a given region in terms of the erosion capability and the erosion base that is there. So what are the potential options for that region are being discovered through the dissection ratio. The next is drainage density. Now drainage density talks about the length of streams of all order divided by the total area. Now higher value of drainage density indicates you have lots of stream and a rapid stream response. So it's the length of all the streams divided by the area, I repeat, and it talks about the rapid response of the stream that is there. Now the next important term that we must know is the ruggedness ratio or the ruggedness index. Ruggedness index is simply the drainage density multiplied by the relative relief by 100. So that is what is the ruggedness index. Now ruggedness index usually explains the steepness of the slope, how steep the slope is. So talking about the steepness is important, and that is explained by ruggedness index. Now ruggedness index, again you have the value of the ruggedness index that varies. You also have various formulas for ruggedness index. Now this is one of the standard formulas that we talk about the ruggedness index. You have another concept where we talk about the topographical ruggedness index being given by Rayleigh, and the concept of Rayleigh is a little different concept. The concept of Rayleigh says that we are trying to understand the amount of difference in the elevation. So elevation 1 minus elevation 2 between the adjacent cells. So you have one cell and the surrounding 8 cells that are there on the digital elevation model would help you understand how the relief actually varies. So topographic ruggedness index is important because you are able to take the square root of this average and calculate it further. The next is bifurcation ratio. Now bifurcation ratio is the ratio which is basically obtained by the number of streams of one order divided by the number of the stream of next higher order. So this is, let's say, of one order, and this is the next higher order of streams. So this is the next order of streams, and that is what is the bifurcation ratio. Now bifurcation ratio tend to decrease when we are trying to move in a downward direction. So what would happen? We have, let's say, a bifurcation ratio of 2 which talks about a flat land. However, when we have a bifurcation ratio of 3 or 4, it talks about a high mountainous area that is there. So that is how we understand the bifurcation ratio. I repeat again, the number of streams of one order in a given contour divided by the number of streams of the next higher order, and that is how we explain the bifurcation ratio. Initially it was given by Strahler. Later on you had Horton who propounded this concept to further details. The next is, when it comes to glacial topography, you have glacial mass index. Now this is important. You have the movement of the ice that occurs in this direction. Now this is the zone of thickening. So this is the zone of accumulation. Okay, then you have the point where it is common, so it's the equilibrium point, and this is the region of ablation where you have the accumulation which is less than the erosion. So here you have a positive deposition because you have accumulation which is much higher than the ablation, and therefore you have thickening of ice that takes place. However, you have the thinning of ice that takes place in the region of ablation. Okay, so when we are trying to maintain a positive response, we are trying to see that accumulation is greater than ablation. Okay, and that's how we understand a glacial mass balance. So here it is positive, here it is negative, and here it's an equilibrium, and this is the ice flow that occurs on a downhill region. So that's how we calculate a glacial mass balance. The next is average slope. Now average slope is very simple. You have the value of average slope that could be written as theta or phi, whatever I can say, that would be equal to the average number of contours multiplied by the contour interval, okay, and divided by a constant. Now this is the Windsword constant. Now Windsword was a British scientist, and he gave the system which was in FPS, the foot pound system. So the average contours were in miles, the contour interval was in feet, and this was divided by a constant 3361. Now the same formula was translated to MKS system, that is the meters unit system. So this average contours crossing would be in kilometer multiplied by the contour interval in meters divided by the constant which is 636.6. Okay, so when this was translated into a meter kilometer system, you had the Windsword constant which changed to 636.6, and in the original translation it was 3361, through which you have to divide. Now this is the way where you find out the inclination of the slope and the topographical features of an area. The next important is the form factor. Now what is form factor? Form factor was an interesting concept that was put forward by Horton, and this concept is interesting because you are trying to get a dimensionless value. It's a factor, so it's a dimensionless value, and this is the area divided by the square of the length of the basin. So square of the length of the basin would again be meter into meter, let's say, and area is meter square, so you would have a dimensionless quantity that would occur. Now this form factor varies from somewhere between 0.13 to 0.77, and that's the range for the form factor. Now form factor is important because it helps us to understand the shape of the basin. So form factors help us to understand the geometry or the shape of the basin. The next and the last two important terms are clinograph. Clinograph, simply put, explains the average slope between two contours. So let's say you have contour of 100, you have contour of 150. What is the average slope between the two contours can be explained by clinograph. And clinograph, I can again explain this with the help of average slope. Average slope we have already calculated. So you have the contour interval, that's another way to calculate it. Contour interval multiplied by the length divided by the area. So that's another way of finding the average slope, and that is important for clinograph because you are trying to find out the average slope between the two different contours that are there. And then what is hypsometric? Hypsometric curve is a curve which explains the earth crust as well as the oceanic crust. So you have the continent. So this region is the continent, the top region is the continent, and the region below it is the oceanic region. So you have a graph which explains both the continental area as well as the oceanic area, and this is plotted in proportion of the area given on the earth's surface. So hypsographic curves are important because it talks about a datum line, the area above the datum line, the area below the datum line. So across the globe, if we consider a hypsographic curve, hypsometric curve, this would be something like this because we are trying to understand the continental as well as the oceanic features. So those were some of the major formulas and the major terms that could be part of your physical geography section. We would be covering many such important small points for your examination. Stay subscribed, stay tuned for many further updates. Have a wonderful day ahead.